Good morning to all. Today we are going to study about physical memory organization. In the previous session we have discussed about memory segmentation, how the memory is being segmented into four different segments logically. So a review about what we have discussed in the previous session. In a whole, we have four segments, which are code segment, stack segment, data segment, extra segment. So these are my segment address register, segment address, segment register. So corresponding offset address for the code segment is instruction pointer. Instruction pointer, it points to the instructions. So where the instructions are being present in the code segment. So instruction pointer will pointing to the instructions where my code segment, where my instructions are present in the code segment. So this is off address, offset address, and this is the segment address for code segment. For stack segment, we have SP, which is nothing but stack pointer, which points to the top of the stack. So if the instruction which is present in the top of the stack is to be fetched, we need to use SP as the offset address in the stack segment. But if you want in middle, in between the stack, then we need to use the base pointer, BP. Getting a point? If the instruction to be fetched is in the top of the stack, we need to use the offset address as SP. If we want to use the remaining part of stack segment, then we need to go for base pointer. Clear? For stack segment, SP, BP. For data segment, SI, or we can call general purpose registers, BX. Source index, or we can also go for destination index, but only for other than string operations, the destination index should be used as offset address for the data segment. Extra segment, this destination index will be acting as offset address only for string operations for your extra segment. This is the thing which we have discussed in the previous session. Today we are going for physical memory organization. So as we all know that 8086 microprocessor has a 20-bit address bus. 20-bit address bus, nothing but 2 power 20. So how many number of addresses we can have in our memory is 1,48,576 addresses. In 8086 there is a 20-bit address bus, so it can address 1,48,576, and at each address location we can able to store 1 byte of data. We can able to store 1 byte of data. But if you want to write a word which is 16-bit into a memory segment to store data in byte form, if you want to store in word form, we can use 16-bit. But if you want to store in a byte form, then we write the data into consecutive memory address, which are even, or I can call as low order memory, even, or we can call as low order memory, and odd or high order memory. So memory address can be divided into memory banks. You can call memory banks. Even memory bank, or we can call as low order memory bank. Odd memory bank, or we can call as high order bank. Right? So if we are going for directly byte form, byte data, only 8-bit data, it is easy. But if you are going for 16-bit data, nothing but word form, then we need to store the memory address into consecutive memory. If you want to write the data of 16 bits at a time, then you need to store the data in two addresses. Even memory bank or low order memory bank, and the second one is odd memory bank or high order memory bank. Data can be accessed from the memory, in 4 different ways. So what are the 4 different ways how the data can be accessed from the memory? First thing, if we have a 8-bit data, so we can able to take the 8-bit data from our lower order address bank or higher order address bank, right? If you have a 16-bit data that need to be accessed, then we can be store the 16-bit data starting from even address or starting from odd address. Even means low address, low order, odd address, even high order address bank. So these are the 4 ways in which data can be accessed from the memory for processing the data. You see here. So like bank, address bank, which is 512K. This is 512K. Okay. So this is higher address bank. This is lower address bank. Each has 8-bit data for 512K and 512 kilobytes. So here, these two are my enable pins in your microprocessor, A0 and BHE bar, bus high enable. So these 2 pins we have in our microprocessor, which are my enabling pins for your address banks. For lower address bank, A0. For higher address bank, BHE bar. Getting a point? So here you can see we have a 20-bit address bus whose address is from A0 to A19, and 16-bit data bus D0 to D15. So if you want to store a 8-bit data, you can able to store in your lower address bank, or you can call as even bank, D0 to D7. The other half can be used to store in higher address bank, or I can call odd bank, D8 to D15, depending upon these two. If A0 and BHE bar, there is one table which you need to look up at, which is how you are selecting the address banks for processing the data or storing the data. So if A0 is 0 and BHE bar is 0, remember one thing, A0 is for low or even, BHE bar is for high or odd. Clear? So if A0 and BHE bar is 0 and 0, if both the enable pins are 0, then both banks active, both banks are in the active mode. Nothing but if both banks are active, what's the thing? It can able to transfer 16-bit data. Nothing but a word can be transferred from, or I can call, or the address A0 to A15, D0 to D15. Get your point here? So when A0 and BHE bar are 0, 0, then we can have both the banks as enabled or active. So 16-bit transfer can be done at one time. If A0 is 1 and BHE bar is 0, then only high odd bank is active. Only high bank or odd bank is active. So only 1 byte of transfer can be done. Get your point here? If A0 is 0 and BHE bar is 1, then only low order or even bank is active and 8-bit transfer can be done on AD0 to AD7. So we have a multiplexed lines AD0 to AD15. So if A0 is 1, BHE bar is 0, then 1 byte transfer on AD8 to AD15. If A0 is 0 and BHE bar is 1, then 1 byte transfer will be done on AD7 to AD0. When A0 and BHE bar is 1, then no bank is active, so no data transfer can be done on this memory. So please be clear with this. Depending upon this two, your selection of even and odd memory bank will be processed. Clear? See, so first 8-bit data from even address bank. So here as you can see, this is my shadow one. So nothing but the data is being transferring from here. But whereas here it is inactive. Because you can see here BHE bar is 1, A0 is 0. So if A0 is 1 and BHE bar is 0, then odd bank by transfer. If both are both are 0, then in both the even bank as well as odd bank, the bytes will be transferred. If both are 1s, then no bank is active, no transfer will be going on in the memory locations. This is how your memory address locations will be transferring the data depending upon the type of data we are processing. So this is about the physical memory organization. If we want to transfer a byte of data, we can use either even bank or odd bank, which is 512 kilobytes each. But A0 should be 0, 1 or 1, 0, A0 and BHE bar. If you want to go for 16-bit data starting, then you have to have A0 and BHE bar as 0, 0. Then only you can able to process the 16-bit of data from even address bank or odd address bank. Clear? Thank you.